Okay, the last lesson we talked about tangents. Remember, tangent hits the circle at one point. Tell you what, let's shrink this down a little bit just to review quickly. All right, so if you had a line out here, and if it was tangent to the circle, what would it do? It would hit, boom, right there, just at one place. Now, remember, technically, a tangent is a line. In that last lesson, though, we had a lot of problems where we just talked about the line segment, didn't we? From a particular point outside the circle to the point of tangency. But technically, the entire tangent is the line. We were just talking about certain segments from one point to the other. But a tangent is a line. Well, we also have another line that we're going to talk about here. And it's not a tangent. But this just hits the circle at one point. What if you had a line like this? How many points does it hit the circle? 2. Now, somebody said earlier, hitting the circle at 3 points. Can you have a line that hits the circle at 3 different points?
Yeah.
You can? Are you just saying that? Come on. Answer seriously, please. Go ahead. Say it. Okay, can you have one line? Here's my question. Can you have one line, okay, that hits the circle in 3 different points? You cannot. No, you cannot. Some people say, yeah, what if it went through here and hit the center? That's 3 different points, but that center's not on the circle, though, is it? Okay, it's inside the circle. I'm talking about on the circle itself. No, you can't. The only way is if maybe it swung around like this, but that's not a line, is it? Do you agree? Line, by definition, actually by definition, it doesn't even say straight, but as far as we're concerned, a line has to be straight. Everybody with me on that? Okay. All right, so what do we call this thing? This thing is called a secant. S-E-C-A-N-T. All right. When you get into Algebra 2, we didn't do this when we did our trig stuff. Remember we had tangent as our trig function? Remember that? And really, this tangent and the tangent of this trig function, really, I don't think have anything to do with each other. The secant is actually the inverse of the cosine. So if I hit 1 over the cosine of an angle, that's equal to the secant of the angle. All right? That's all I'm telling you right now. Don't worry about that. You'll hit more of that when you go into Algebra 2 and you do some more heavy-duty trig. I could have mentioned it to you in the last chapter when we did the trig stuff, but we're not really using it in geometry. But in Algebra 2, and in pre-calc especially, and further, you will see this word again. It's called the secant. All right? But right now, all we care about is a secant is a line that hits a circle in 2 points. That's that. Now, I would really take some notes if I were you, because this tends to kind of jumble up. I don't think each one in and of themselves are that difficult of these theorems. It's just trying to keep them all straight is the hardest part of this. All right, so take good notes. Don't just sit there with your arms folded or your head down on your desk thinking that you're going to get all this stuff. Let's see. Yeah, that doesn't have to be in the center. Let me see. If 2 secants intersect in the interior of a circle, then the measure of one angle is half the sum of the intersected arcs. Alrighty. Watch this. I'm going to have 2 secants, and they intersect. Now, on this example for this theorem right here, they have them intersecting at the center. They can intersect at the center, alright, but they don't have to. I think maybe they did that for the proof. Alright, but I'm just going to show you this. Just say that they intersect each other like this. All right. I'm not going to draw the arrows every single time. Is that all right? But you realize the secant does keep on going forever. But I'm not really concerned so much about that right now. All right. Let's use this color. Kind of stands out a little bit. What I want to do is look at this. Okay. I just wanted to reread what this thing said. Let's label this thing, just so we're not talking about this arc and that arc. A, B, C, D. All right. What do we have here? We got some arcs that are formed, don't we? So I've got arc AB, and what's the opposite arc of AB? CD. Do you see that? Because these are vertical angles to each other. Do you see it? Or opposite angles, whatever you want to call them. We call them vertical angles. So this is the arc formed by this angle, and CD is the arc formed by this angle. Now, does this arc equal this angle right here? No, it doesn't, because it's not a what? central angle. It's not a central angle, but there is a relationship here. What I want to do is I want to just highlight those two arcs for you. Okay, see that arc right there? And if I can stay on this line. Oops. Man, almost had it. There you go. And that arc right there. See these two arcs right here? There's definitely a relationship between what we're going to do. Now, this is probably not one that you would have just figured out yourself, but it's actually kind of interesting. If I was to measure the angle formed. Okay, see this angle right here? And we'll call that, I don't know, let's just call this angle, I already got C, X. Alright, if you want to call that angle X, you can call this angle X. I'm sorry. We'll call this point X. Alright, so AXB. Do you see that arc right there? So this arc, or sorry, that angle, and this angle right here, what do we already know without knowing anything else? We already know what's true about those two. They're equal to each other, okay? So, if I wanted to find, if I knew some information here, I could know the angle, or I could know the two arcs, okay? But if I know, or I could know one angle and one arc. Anyway, let me just show you this. This angle right here, angle, what do we call it, AXB, is equal to half the sum of the two arcs that are cut off by those two angles. All right? It's a little wordy, and if you think that's wordy, you should read the theorem in the book. I'm not even going to read it to you because it's very wordy. But I just want to show you visually what's true. This angle right here, either this one or this one, it's the same angle, right? This angle right here, if I took this arc that is cut off by this angle, and I took this arc down here, CD, that's cut off by this angle, this vertical angle, if I added them up and took half of them, half of that measure, then I could figure out what this angle is right here. So it's equal to half the sum of these two arcs. So arc AB plus arc CD. So again, what do? You take the two arcs that are highlighted right here, you add them up, okay? You take half of them, and that's what this angle is right there. It's basically kind of like the average, isn't it? This angle is kind of like the average of those two arcs. So you take the two arcs, you add them together, you take half of it, and then that's what this angle is right there. Yes?
But it doesn't make sense because if angles are the same, are the arcs supposed to be the same?
Doesn't mean, no. No, because it's not a central angle. It's not a central angle. If this was at the center, then yes. Then this arc right here would equal this angle. All right? And this arc right here would equal this angle. All right? So if it was at the center, it would actually make more sense because I could take an angle and an angle that's double this, right? Take half of it, and then I've got this angle right here. So that's why they do that as the proof. That's why they put this at the center. But it doesn't have to be at the center.
But if it's not a central angle, doesn't the angle, the angle be, twice?
No, that's a inscribed angle. Okay, that's why I said each one of these by themselves is not that difficult. It's keeping everything straight is the hardest part of this. Yes, Travis.
Does that work for every vertical angle?
Yeah, it also works for this. Watch. Let's do this in another color. I think this is what you're asking, Travis. About this arc right here. Is that what you're asking? Yeah. And this arc right there. Do you see that? Oops. Let's make that smaller. Okay. Watch this. See this? So what would this angle be right here? We'll call it angle what? AXC is equal to half the sum of the two arcs that these angles cut off. What angles do these, or what arcs do these two angles cut off? AC and BD. So if I took AC, arc AC, and I added it to arc BD and took half of it, that would equal this yellow one. You see it? So you can go either way. So the pink ones, that angle, those pink angles right there, are equal to the sum of the two arcs and then half of it. All right, so add them up, take half. Make sense? I don't know. Let's just put some numbers in here. I have no idea what to make this. Let's make this 40 degrees. Yeah, it's close enough, and make this 60 degrees. All right. So if I told you arc AC was 40 and BD was 60, how would I find this arc or this angle? I keep saying arc. This angle inside of here. What would I do? Well, add them up, 40 and 60, right? And then do what to them after I add them up? Take half of them or divide by 2, right? Now I put 1/2 out in front. That's the same thing as dividing by 2. So let's show the work. 100 divided by 2 equals what? 50 degrees. So this angle right here would be 50 degrees. Everybody see that? Okay. All right, that's pretty straightforward, I think, don't you? Again, the more of these type of things that we get, the harder it is to keep it all straight. So you really have to study it. Okay, you got to go back, look at your notes, take good notes, and review them every single night. All right, watch one of these videos once in a while. Okay, just to keep the stuff straight so it stays in your mind. All right, here's an example of what we just did. Now look, these are still secants, right? It's just like a part of a secant. Remember, the secant would keep going through, but I'm just going to take a look at from where it hits a circle, where it hits a circle, because really the outside of these particular secants don't really make any difference as far as what we're concerned, at least in this particular problem. So, what do we have here? We got this is 110. So that means that this angle right here is also 110, isn't it? Okay. But look at the arcs that they form. Do you see this angle forms this 97 degree arc? This 110 right here forms what? This arc of x degrees. All right. So those are the two arcs we're going to do. So what's our little rule? The angle. So the angle, which is 110, equals, what do I do to the two arcs first of all? I add them up. So x plus 97. And then what do I do after I add up those two arcs? I divide it by 2. And there it is. Now it's just algebra. We did the geometry. See, the angle is equal to the sum of the two arcs divided by 2, or half the sum of the two arcs. You see it? See, that's the arc that's formed by this angle. This 97 degree arc is formed by this angle right here. You take those two arcs, you add them up, divide it by 2, and it equals that angle. And then you just do your math. Let's do it. Multiply both sides by 2. That gives you 220. And then you just subtract 97 from both sides, and then there's your x, whatever that is. 123, is that right? That's all there is to it. It's probably the most complicated this type of problem is going to get. Okay? Simple as 1, 2, 3. That's right. All right. Let's learn something else. Okay, what we're going to do here is I'm going to draw two secants, but these two secants are going to intersect outside the circle. All right, so here's a secant right here, and here's a secant right here. But look what they do. They intersect outside the circle, and they form this angle right here. Now, there's something about this angle and these arcs that are cut off. Do you see this arc right here? It's cut off by those two secants. You guys paying attention? And where's the other arc? That would be this one right here. Okay? So the math is still the same as what we did before, except we have a different situation here. We have two secants that intersect at a point, but the math is exactly the same. If I wanted to find out what this angle is outside the circle, okay? This is not inside the circle like it was before, is it? This is outside the circle. We're basically, well, it's actually not exactly the same thing. We're not going to add the two arcs together. What we're going to do is we're going to actually subtract the two arcs from each other. And let's just put some letters in here. We'll call this A. Let's make mine a little smaller. And then this B, C, D, and E. Alright? So watch. Angle A. If I wanted to find what angle A was, this is different because this intersects outside the circle. Earlier I said it was the same math. It's not. Okay, it's just a little bit different. It's still half, but it's not the sum of the two arcs. Alright, it's going to be the difference of the two arcs. So what we're going to do is we're going to subtract the two arcs from each other. Which one's the bigger arc? DE. So that's going to go first. So arc DE minus that little arc, which is BC. Right? That's supposed to be an arc symbol right there. That's kind of ugly. Alright, so if I want to find the angle outside, this is outside the circle. Before, they intersected inside the circle. This intersects outside the circle, so we take the two arcs, we subtract them from each other, not add this time. We subtract them and take half of it. Okay? Let's do another one. So right there we did two secants that intersect outside the circle. So this time what we're going to do is we're going to do one secant, and then we're going to do a tangent. So where's the tangent going to be? About right there. All right. Look, it also forms an angle outside the circle, doesn't it? So let's take a look at the arcs that it makes. So watch. This makes this arc right there. To see, there's the point of tangency. So that's that arc. Where's the other arc that those two lines make? This secant and this tangent. Well, it's from here all the way, oops, to here. Actually, let's do that in a different color. Blue. All right. So there you go. Do you see those two arcs that are formed right there? Those are the two arcs formed by the two lines, by this angle. This angle cuts off this yellow arc, and it cuts off this blue arc. So guess what we're going to do? To find this angle, we're going to subtract the two arcs from each other, and then take what? Half of it. All right, so that's what we're going to do. Take the blue one minus the yellow one, and take half of it. So let's just call this, A, B, C, and then just call this D. There's no E on this one, is there? So angle A, in this case, would be what? Half of arc DC minus arc BC. So there's our situation. We've got two secants. This one we have a secant and a tangent. You got it? But the math is exactly the same, isn't it? All right? So let's do another one. So we had two secants. We had one of each. One secant, one tangent. What do you think we're going to have now? Two tangents. Yeah, let's do that. That intersect outside the circle. Now we've already had that situation before, but we're going to find something different here. Actually, two tangents. So that would be a tangent right there, and that would be a tangent right there. So let's draw. Let's go orange this time. Look at the arcs that are formed now. Do you see it? Here's the angle that I'm dealing with. And what arcs are formed? Well, it would be this one right there, and it would be this one right there. They actually form that whole entire circle, don't they? All right, but guess what we're going to do? We'll call this A, we'll call this B, and we'll call this C. Tell you what, we need another point in here. We'll call this D. All right. So watch what's true here. Angle A is going to be half. What do you think? Something minus something. The math is exactly the same as what we did before. What is it? We take the bigger one, which would be what? BDC, right? Minus this short one, BC. See, I can't say BC minus BC, can I? Because I got to have another point in here because I don't know which one I'm talking about. So I call this BC. Okay? That pretty much takes us to the end. Now, there is one theorem on the bottom of page 728 that I didn't hit. It's pretty close to what we have right here. It's pretty much the same exact thing. You can look at it and figure that out. Let me give you some problems to do. Then you can go. So it's section 10.6. It's page 723, just one page. Oops, 723. I'm sorry, I lied. I wrote it. I was starting to write it right, but I said it wrong. 732. My bad on that. 732. And it's 8 to 23. There you go. 8 to 23, page 732. 732.